Hey everyone, and welcome to this video on how to boost the accuracy of e-commerce search results with Atlas Vector Search. My name is Francesco Baldissera, retail consultant in the Industry Solutions team here at MongoDB. Let's jump right in. First, I want to talk about how search impacts customer behavior on e-commerce websites. According to recent studies by Comscore and e-consultancy, on-site searches are almost twice more likely to convert than regular users. They found that on average, up to 30% of visitors will use the search box, and visitors using search contribute to almost 14% of revenues on average. It altogether seems like search is a pretty important part of any e-commerce business. However, there's still room for improvement for any retailer wanting to win in their market. Search presents a big chance for achieving success through innovation. Only 50% of site searches typically find what customers are looking for. Visitors who had a no-result page are 3 times more likely to leave the site, and slow search results decrease conversion rates by 7% per second. One way to enhance an e-commerce search experience is by using AI. AI can be used to improve the relevancy of those results. Search relevance is the measure of accuracy of the relationship between the search query and the search results, showcasing the right products at the right time and at the right price. To do so, your application needs to have the ability to give more business context to the way you organize and display your search results through intelligent scoring. This is exactly what differentiates AI-enhanced search from traditional keyword matching search. In this demo, we'll see how to build search results scoring by building an AI model that will help rank the results based on the relevancy for both businesses and users. AI models could also be used to account for personalization in search results by using features built on top of customers' data. The scoring model will take its input from different customer data points, such as segmentation, customer lifetime value, and cost of acquisition, providing the most relevant search results for that specific customer. These features are certain to deliver improved user experience. All this sounds very cool, but what about the challenges you could face trying to integrate AI into search? Well, the feature will have to deal with a wide variety of data and its associated complexity in real time. You'll need to train models with fresh data and orchestrate in-app analytics. Your team will have to cope with being asked to build performance and robust features such as search discoverability, hyper-personalization, and feature sorting. So fine-tuned models and systems are essential to achieve what customers expect when interacting with search. Providing easy-to-use and integrated tools for your developers becomes the central point for the success of your value proposition. So, what does the architecture look like, and how does the data flow through it? In the first step, the data is ingested through the Apache Kafka connector. We will be pushing the user events, click logs, into a MongoDB Atlas database. The rest of our database collection contains product attributes, available to promise status, price data, and using the MongoDB connector for Spark, an AI model running in Databricks can be trained with fresh data. Once we add the data in Databricks, it will run 2 different jobs. The first one is to process the product data stream and perform data wrangling so we can build the feature store for our models. The feature store will be a collection of different behavioral and categorical data such as click logs, numbers of times a product has been searched, available to promise status, and other behavioral variables. After that, we run a machine learning algorithm that will use the features from the feature store as input and provide a product status score as the output. In the second job, we will build another machine learning algorithm that will take input, historic pricing data, and sell-through data for each product, and compute their competitive price. With the use of change streams, a real-time stream of database changes that flow from MongoDB collections into Databricks notebooks, we move the historic price data as input and get a recommended price as the output. That recommended price is inserted back into the MongoDB Atlas collections. So with this data, the search results will have the relevance augmented by implemented Atlas search features such as autocomplete and indexing. Using the scoring and price elasticity fields as sortable numbers in the mapping, we can build the app search business logic very easily. Now let's see what the solution looks like in the code and in the front end. Let's look at how we can augment our retail search experience with AI using MongoDB and Databricks. Our website is demonstrating full text search, autocomplete and scoring powered by MongoDB Atlas Search. Upon doing a full text search for handbags, we can see that the products are retrieved and sorted based on different factors such as price elasticity and business intelligence score. The business intelligence score for each product is calculated using different events such as click streams, views, and add to carts. But how are these events captured? We use a Kafka Sync connector to write all these events to a Kafka topic and then ingest these events into a MongoDB Atlas collection. So, as you can see, all the events that we perform on the website for this particular product are available on the Kafka topic. Moving along with near real-time indexing, which can be achieved using Databricks workflows, there are two main stages in the indexing workflow. The first stage is building the index and pipeline. We use the MongoDB connector for Spark to pull data from various collections in real time and prepare a single view of the data, which is then returned into the catalog collection. In Atlas, you can see how we are retrieving all the events, and then we will pull data from available to promise status, product descriptions, personalization score, and competitive pricing. All of this is computed in real time. In the second stage of the indexing pipeline, we then pull in the single view of data from the catalog collection and add the discounted recommended price for each product, which is computed on the fly. We then update the available to promise status based on certain checks, and the final view of the data that is generated out of this is written into the catalog's final collection. Let's see this in action. I'm going to add a product into the cart, and I can see that it is added to my Kafka topic, and then go ahead and check out this product. Once I check out this product, the event is captured in the click logs collection through the Kafka topic. Similarly, there is a change in the indexing pipeline, which is captured by the MongoDB connector for Spark in real time and will update the respective single views of data in the MongoDB Atlas collection. Once the changes are done, the product is out of stock and not available for purchase. This can be confirmed from the search listing page as well. Now let's see the dynamic pricing workflow set up on Databricks. There are two stages in the pricing workflow. In the first stage, we're going to be building a machine learning model and registering it. In stage 2, we're going to see how we can use that registered model to tag real-time data with the output of that model. First, we will pull data from MongoDB Atlas in a materialized view and use aggregation pipelines to generate a new view of the data that we prepare to train our machine learning model by following the MLflow framework. Now let's see the second stage of the pricing workflow. I'm going to open the notebook here, and you're going to see that we're going to be pulling sales data from MongoDB from a process collection, which is periodically updated data in the materialized view that we saw earlier. Here is the process collection for the trained data. So we're going to be registering the model once it's already trained, and we're going to be pushing it to the staging environment. Then this model is going to be used to tag and predict the optimal amount of discount and the discounted price of each one of the products. we're going to decide if this is going to be displayed on the website in real time. For the time being, we're going to be pushing it to the staging environment. Here you can see how we're calculating the predicted price, optimal price according to different discount levels, and the price elasticity. This is being pushed in real time to this collection, which is the price aggregated collection. With this, the demo is complete. If you have any questions, feel free to reach out to our Industry Solutions team or the subject matter expert on retail and Databricks in the description bar below. Thank you for watching.